This video is not what you might expect. It's a bit different from the usual Jamaican bauxite videos here on YouTube. Many of those videos talk about Jamaica's rich bauxite legacy, how we've been a major exporter, how the industry earns foreign exchange, and of course, the environmental impact of mining. In fact, the vast majority of what's out there focuses on the economic and the environmental sides of the story. There are even people who go as far as to say we should do away with bauxite entirely, arguing that Jamaica gains nothing from it, often with some big gaps in their research and a complete avoidance of things like economic spillover effects, Anyway, I'm not here to discuss the mining history or the environmental impacts or whether Jamaica should continue mining bauxite or not. The internet is already flooded with that conversation, and truthfully, I want to avoid that drama, at least for now. This video is here to ask a different question. Why does Jamaica have bauxite in the first place? How did this mineral that has enriched some and caused pain to others become so abundant on our island? In this video, we'll explore the main theories and hypotheses about Jamaica's bauxite and identify which one is most widely accepted and supported by scientific evidence. So it's a welcome change, I think, from the current debates that tend to divide people. So stay tuned as we investigate the true origins of Jamaican bauxite. So before I get into the theories and hypotheses about Jamaican bauxite formation, I thought it would be prudent to start with a basic introduction to Jamaican bauxite for the uninitiated. So what exactly is bauxite anyway? Put simply, bauxite is the chief ore of aluminum. Basically, it's the rock we get aluminum from. The metal used to make things like pots and pans and drink cans, parts of airplanes, and many other everyday items. From a geological standpoint, bauxite is a chemical or residual sedimentary rock. It forms through intense tropical weathering of other rocks, and over time, long periods of time, rainfall washes away most minerals, leaving behind material that is rich in aluminum. And that, in a nutshell, is bauxite. In Jamaica and many other parts of the world, bauxite is mined using open pit mining, also known as open cast mining. This is a surface mining method where large stepped pits are dug to remove overlying rock and access minerals close to the surface, using heavy machinery to extract the material. Open cast mining isn't used only for bauxite. Other commodities like gold, copper, and coal also use this same technique. Now, mining is only part of the story. When it comes to bauxite, like most other metallic minerals, the raw ore still needs to be processed. This is where the Bayer process comes in, and it was developed by Carl Bayer. It is the principal industrial method used to refine bauxite into alumina or aluminum oxide, and we can simplify it as follows. Step 1, crushing and mixing. The mined bauxite is crushed into small pieces and mixed with a hot chemical solution called caustic soda or sodium hydroxide. Step 2, dissolving. When heated, the aluminum bearing compounds dissolve into the liquid. Unwanted materials like iron oxides and sands do not. Step 3, removing waste or red mud. The remaining solid waste is filtered out, and this waste is known as red mud. Step 4, recovering alumina. The liquid is cooled, causing the aluminum compounds to come out of solution as a white solid called alumina. Step 5, final heating. The alumina is heated to remove water, leaving behind pure alumina powder. I plan to go into much more detail on the Bayer process in a future video, but for now, we'll keep it simple. This video is really about how bauxite forms. We'll explore the mining and industrial processes in more depth later on. So with that said, let's move on to the other segments. So now it's time to explore the ideas behind Jamaican bauxite formation. Let's start with the residual hypothesis. This idea proposes that bauxite formed directly from the chemical weathering of Jamaica's white limestone. As the limestone slowly dissolves over time, the tiny insoluble particles, mostly clay-like residues, were left behind and gradually build up to form bauxite. It sounds simple, right? And logical. After all, bauxite is often found sitting right on top of the limestone across central and northern Jamaica. But here's the issue. Geochemical studies show that the limestone itself contains too little aluminum to produce such massive bauxite deposits. In other words, if bauxite came purely from limestone weathering, we'd expect to see much less of it than what we actually see in Jamaica today. So, while the residual hypothesis explains the location, it struggles to explain the volume. Alright, so next up is the volcanic ash theory, which is currently the most widely accepted explanation. This theory suggests that the source of aluminum wasn't the limestone at all. It was volcanic ash that fell across the island over a long period of time. Imagine ancient Caribbean volcanoes erupting explosively, sending plumes of ash high into the atmosphere. That ash, rich in aluminum, titanium, and other elements, drifted across the region and settled on Jamaica's limestone surface. Over time, intense tropical weathering and leaching removed soluble materials, leaving behind the aluminum-rich residue we now call bauxite. And there's strong evidence for this. Geochemical analysis of Jamaican bauxite show a composition that matches volcanic materials much more closely than the limestone. For instance, the presence of titanium, zircon, and rare earth elements points strongly to a volcanic origin. So in short, the volcanic ash theory fits both the chemistry and the geological context. So the third idea now is the alluvial hypothesis, and this was championed by geologist Werner Zanz. I discussed him in my video here on Jamaica's first geologist, so you can check that one out. Zanz suggested that bauxite wasn't formed from in-place weathering at all, but rather from alumina-rich sediments washed into limestone depressions through ancient rivers and underground karst systems. Essentially, material from igneous rocks elsewhere was carried into basins where it settled, weathered, and eventually formed bauxite. It's a creative idea, and it helps explain why bauxite often sits in pockets of or hollows within the limestone landscape. However, it has only one big problem. Many bauxite deposits occur at high elevations, far above where alluvial sediments could realistically have been transported. So, while water movement likely played a role, it probably wasn't the main driver of formation. So, what is the current consensus? Well, most researchers today favor the volcanic ash theory as the dominant explanation, and it's supported by geochemical and mineralogical evidence. However, many geologists also believe that it's not purely one process or the other. It's possible that volcanic ash was the main source of aluminum, but the local hydrology and streams and groundwater and karst activity help transport and concentrate that material into the depressions where we now find bauxite. In other words, Jamaica's bauxite story might be a hybrid of both the volcanic and alluvial processes, and it's shaped by our island's unique tropical climate and limestone geology. So, to summarize, the volcanic ash theory is the most widely accepted explanation for the formation of Jamaican bauxite. The residual and alluvial hypotheses don't fully stand up to scientific scrutiny, though elements of both might have played minor roles. And based on some anecdotal chats with my geological colleagues, there may be another theory in development somewhere. Hopefully, if the results look promising, something will be published soon, and when that happens, I'll be happy to discuss it here on the channel in the future. I also want to say a special thanks to a colleague of mine in the industry, Latoya Thomas. She provided the lovely photos of the in situ bauxite out there, which I had shown you throughout the video. So thank you, Latoya, for all your help. So until next time, everyone, thanks for watching and please take care.